So for this video, we're going to talk about logic operators. So we've been basically talking about Boolean expressions abstractly, but let's actually talk about the Boolean variable. So Boolean b is equal to true or something like that, right? So let's go ahead and say if true and else. Let's put a print line for each of these. System.out.println truthiness. All right, so we've got our if else statement set up. Well, so we've got something that'll print out if this if statement is true, if whatever we put out in here is true, and we'll have something else here that prints out whenever this is false. And notice that the compiler says this is dead code. It's giving me a warning that basically that this won't ever be reached because true is always true. So we run this, and we get truthiness. Okay, so now if we put false, it's going to flip around a bit. It's going to say only the false will ever print out. So now let's go ahead and put, let's say something like b is equal to true. Okay, so this is a pretty common check where basically you'll have some Boolean variable, and it might be something like rather than b is equal to true, b is like something like this. Int x is equal to 5. Common example that I keep using is 5 greater than or equal to 5. Well, not 5. X. And let's put it in parentheses so that's easier to read, right? So it's truthiness, right? Because we'll store 5 in x, and then we'll store 5 is greater than or equal to x, which resolves to true. 5 is greater than or equal to 5 in b. And then over here we're asking, is b equal to true? Is true equal to true? Okay. So cool thing about Boolean expressions though is that we kind of don't really need this. Right, I'm just going to skip to this being. I'm going to cut out what I put there. I'm just going to put true there for right now. We don't really need that double equal sign there. We can just do b, because this is a Boolean expression. Remember, b is a Boolean variable, and it means that if I just put it by itself, it's its own expression. So I do if b, it prints out truthiness. And now if I set b to false, well, assuming I can spell, boom. So that seems pretty good so far. Okay. All right. So we can establish that basically we can put any kind of Boolean expression we want in there. So let's start talking about some of the more interesting things we can do here. And I'm going to copy paste from our previous program where I had stuff listed. So here's the things we learn about when we talk about Boolean expressions, right? We've got these operators, less than or equal to, greater than or equal to, less than, greater than, is equal to, or is not equal to. First one on this column that we definitely want to talk about, that I think we've already talked about, is the not operator, which just simply flips this. So I can put not b over here. So Boolean not, so Boolean b is equal to false. Not false, well, the flip of that is true, so this is now going to print out a true statement. And not b, well, the inverse of the inverse is they nullify, so just false. You can stack these as many as you want, but why bother? That's just going to get confusing, right? Sounds like something that might happen on an exam, though. Right, so we've got that. So we've got our not operator. Okay, so we've shown you, I think, that basically if I do something like if 5 is greater than 2, right? And now if I throw a not, now that would be true, but if I throw a not in front of there, it's a false statement. Okay? So, not will simply just flip over whatever it's attached to. And that's generally whatever you throw in parentheses. You can't just throw it here, or can you? Right? Nope, because it's a unary operator, it tries to attach itself to the 5. So, it needs to be attached to a Boolean statement. Okay, which by the way means that, and we'll get into this, Boolean statements, these Boolean operations, they have an order of operation. They have some precedence, right? Int x is equal to 5. Do this again. And it works exactly as you'd expect. Let's just remove the not to keep it simple. Right? 5 is greater than 2 plus x, right? And you would parse that as, well, let's check if 5 is greater than 2 plus, the sum of 2 plus x, right? We'd add 2 plus x to find out if that's bigger or smaller than 5, right? So they'll ask, is 5 greater than 7? Which is not. So we do all our mathematical operations first, then we start looking at less thans and greater thans, and the double equals and all those stuff. So all the arithmetic expressions take place before the Boolean operations, right? So what else do we have? Well, suppose that we want to do something, and this is a common question I've asked in my test, where basically I ask somebody write an if statement that checks, that checks to make sure that x is a single-digit non-negative number. Okay, a single-digit non-negative number. So what does that mean? So single-digit non-negative, well, that's all the positive numbers, 4, 5, 6, 7, 8, 9, which are single-digit positive numbers, and then you have 0, which is a non-negative number. Okay? So now here we can't just do one statement. We can't just say that x is greater than or equal to 0, right? Because while this works for all of these, right, we want it only to print out true for our single-digit non-negative numbers, right? So we put in 10, it says it's true, but we only want the single-digit numbers. We want it only to be true if we put in one of these. So we need more than one condition. So one way to do that is that if you don't know about these guys over here, is that we can go, well, if this is true, we can kind of load this up. If x is greater than 0, or greater than or equal to 0, if x is less than 10, right? So it's got to be, so now let's parse this. Because we can chain these if-else statements as far down, but a lot of times we don't need to. So if x is greater than or equal to 10, well, now we go and execute what's inside this if statement. If x, greater than or equal to 0, and then if x is less than 10. So now, when we run this, it prints out absolutely nothing because it skipped over this bit, because it was 10. So now if I put in 6, though, it's greater than or equal to 0, it's less than 10, it's going to print out truthiness. But now if I wanted to print out something else, I've got to copy this bit over here as well. It kind of gets a bit messy, right? So it'd be nice if we could check both conditions to make sure both of them are true. And that's where our AND statement comes in. So AND is represented by 2 ampersands, right? There's also a single ampersand operation in Java, which is completely different than 2. You rarely are going to use it unless you're dealing with a lot of binary stuff. So you always want 2. It's easy to remember that you want 2 because you're also going to want 2 for OR. So we've got 2 ampersands to say we want this condition on the left and we want this condition on the right to be true. X is less than 10. So if x is greater than or equal to 0 and x is less than 10, then we'll do system.out.println truthiness, right? Both of these conditions have to be true for it to be good. So now if I try something like -7, it tells me it's lies from beyond the outer realms. And if I try to do 10, boom, also lies. All right. So for these, both of these conditions have to be true. It's not sufficient for just one of them to be true. Both of these have to be true, right? It has to be this and this. It has to be both x has to be both greater than or equal to 0, and it has to be less than 10. That's possible for both of those conditions. So it is also possible to write an and that, that doesn't make any sense, but that's just something you'll have to be aware of. Most of the time, though, ands are fairly straightforward to write. Let's say we only want this to be an even number as well. So remember, the way we can check if x is even is by modding it by 2 and checking if that equals 0. So it failed here because it was not less than 10. So 6. So it's both greater than 0, less than 10, and it's when we do x mod 2, it gives us 0. So these AND operators have an even lower precedence than these Boolean operations because we have to evaluate this fully, right? We have to evaluate this Boolean statement to true or false, and then compare this one, and we have to make sure both are true, and then this one. Now, although I should mention, Java's actually fairly smart. As soon as it figures, if it sees a bunch of ands like this, as soon as it sees 1 isn't true, like if I were to put -1 over here, it's going to do something called short circuiting. So if I run this, it's going to short circuit on this one. It's just going to stop. It's not even going to bother checking the rest of these because it already knows that one failed. And so since they all have to be true, none of them, since they all have to be true, since one failed, the entire thing's going to fail, and it's not even going to bother check. And that's just some human logic you can use on like exams too, or when you're trying to parse these. So the way this works is that it does go left to right. It evaluates this to true. Sorry, so if I put in something like 6 over here, it's going to evaluate this to true, and then it's going to check this and say that's true, and so it's going to go true and true. Since they're both true, this entire statement becomes true, and I don't need to put the parentheses in, but they're just there as a guide. And then it's going to go true and x mod 2 equals 0. So it's going to go and check that. Is that true? Yes, it is. So let's go ahead and check to make sure it works for just even numbers. Bam. So it fails there. All right. So what about this other thing I have here, the 2 pipe symbol, the 2 bar symbol? This is OR. So sometimes we might decide to change this around. All right, so say we've got this expression here, and we decided to do this. Well, that's still going to be true. But now if I put in 10, it's going to be true. And what's going on over here? Well, I've changed my condition. I threw in an OR. Well, let's first discuss what an OR is. An OR operator says that either the left, so if you've got 2 Boolean expressions, right? Let's go over here and actually let's just what we have here. I'll just copy this out temporarily. Boom. True or true. If both things are true, then this is fine. True or false. Now with an AND, this would fail, right? But with a true OR, it's true. Right? With an AND, if you've got true on one side and false on the other, it's going to fail. But with a OR statement, if either side is true, the whole thing becomes true. So it's just one of these conditions have to work. And if it does, the whole thing works. Okay? So, and it can be the other way around. False. False. So false, true. So, as a result, the only way this is going to not run, or it's going to be lies, is that if both of the conditions are false. Right? Right? So now we've got a bunch of these statements together, and because one of these 4 is true, the entire thing is true. So let's go ahead and look at these statements again. If x is greater than or equal to 0, or it's less than 10, so if it's between 0 and 10, but not including the 10, or it's an even number, we're going to say it's true. So since 10 isn't in this range, but it is an even number, so it's going to return true. Cool. So let's go ahead and look at some of the exercises from the slides now. So they've got a couple other ones here that you can review yourself. One easy way to do this is to make a truth table, which you should learn in your math concepts class. Which is simply to say is that if you've got combinations, you can kind of produce a combination. If you've got combinations of left and right, and you can figure out what to put down in a table. And here they are talking about the precedence, right? That we want to establish, that we do all the arithmetic operations before we start doing these Boolean expressions. And I forgot to go over this. Relational operations, but I kind of implied it. You can't... Here's how I had to say this is x is greater than or equal to 0, and it's less than 10. But in math, I could have just done, if I was writing this in algebra, I could say x is, 0 is less than or equal to x, and x is less than 10. I could have done this, right? But Java doesn't know how to parse that. Doesn't know how to read that. So you have to use this AND condition to say both are true. I can also totally just flip this around too. And that's perfectly fine. But you can't chain these things together because it goes left to right. 2 is less than or equal to x. That resolves to true. True is less than or equal to 10. That's not going to work. So instead, you have to use the ORs or the AND. Sorry, you have to use ANDs and ORs to fix that. So now, let's look at the results of each of these following expressions. So try to figure out what each of these things evaluate to. So you might want to pause here for a second and see if you can't figure that one out. So, were you able to figure it out? Let's go through it. So let's see. Y is less than x, 17 is less than 42, and 17 is less than or equal to 25. So 17 is less than 42, that's true, and 17 is less than or equal to 25. That's true, both sides are true, so the whole thing is true. Okay. Ooh, this one looks nasty too. X mod 2, if x mod 2 equals y mod 2. So remember, we figure out the math first. Okay, so let's do x mod 2. So the remainder of x when it's divided by 2 is 1. Sorry, 0. 0, right? X mod 2 is equal to 0. Y mod 2 is equal to 1. So those don't match. Okay, what about here? 0 and 1. So these are both false. So these aren't equal and these aren't equal. So that's a false operation. Okay? X less than or equal to y plus z. So 42 is less than or equal to 17 plus 25. So that actually, what's 17 plus 25? Well, 7 plus 5 is 12. Carry the 1, 42. So this is true, and y is greater than or equal to y plus z. So it's both less than and equal to and greater than equal to y plus z. So this entire statement is true. All right, x is less than y. 42 is less than 17. Okay, we know this is false. All right, let's see. We know this thing is false over here. Ooh, what can I do with these? So we know this is false, right? Now what's cool is that because we see this and over here, false and I don't care what this is. That could be whatever I needed. Whatever. I don't care anymore. This is false and something else. Doesn't matter if it's, well, if this is true, don't care what it is. False and true becomes false. If it's false, false and false becomes false. So this entire thing is false. But now we've got this not over here. And that not means that this false gets flipped to true. Cool. All right. So now we've got x plus y mod 2. So remember, this was 42. Wait, no, sorry. X plus y, sorry, I thought it was doing y plus z. So 42 plus 17 is equal to 59 mod 2. So 59, what's the remainder after 59's been divided by 2? It's 1. Equal to 0. So does 1 equal to 0? No, it does not. So it's we'll just put an F here. Not for a failing grade, but for false. Right? And then we've got, so if this was an and, we'd be able to stop right now. But it's not. We have to check the or statement over here. So or not this. So y minus z. 25 minus 17 is, see, 8. Mod 2. So that gives us 0 equals 0. So that means that this statement becomes true. But we have this. False or false becomes false. False, true, false. Sorry, false, true, true, false. True, true, false. Right? So hopefully I got that all right. Otherwise I've made a butt about myself. Okay. So, let's see. So, I think actually this is a good place to stop. Discard my ink annotations. So, I'm going to go ahead and upload this video as well. This should be more than enough to get you through your homework at this point.